So in this recording, I'm going to share my exploration with the AWS Bedrock Agent Core long-term memory. I'm still exploring it. I have not completed the exploration, but I'm going to share what I have explored so far. So in AWS Bedrock Agent Core, when I create a long-term memory, I can attach memory strategies to it. Right? So there are three built-in memory strategy, and you can have your custom strategy as well. Right? The three built-in strategies are the user preferences, the user preference memory strategy, which deals with extracting the user behavior, the interaction styles, choices. So this enables the agent to automatically adapt the responses matching the user preference. Right? Then there is a semantic facts, right, which maintains the knowledge of facts and domain-specific information, technical concepts, and the relationships. And this allows the agent to provide informed responses based on previously established context and understanding. And the third one is a session summaries, right? So it creates a condensed representation of the interaction content and the outcomes for a particular session, right? I explored this one and this one, the session summaries and the user preferences. I could not get the session summaries to work. It may be a bug. I have actually reported this as an issue under the Agent Core SDK. But I was able to use the user preferences, but we'll go through both this and show how I actually coded it and tried to use it. Semantic facts is something that I am yet to explore, as well as the custom strategy. One of the things that I'm still not able to figure out is how do I map it to my definition of memory systems, like which I say memory is a system of systems, right? There are multiple memory systems within that. If we actually compare it with the human memory, right? We have an episodic memory, we have a procedural memory, we have a semantic memory. Semantic memory, probably I can use this, but to extract episodes and all, I need a schema, right? Like how LangMem does it, right? So where you give it a schema, and based on the schema, I can extract the episodes. That part I have not been able to figure it out yet. Probably the custom strategy will allow me to do that. And that is the next exploration that I'm going to do. The other thing that I found out, and it is not in the documentation, is the architecture of Bedrock Agent Core memory. It looks like there are two components. One is the control plane, memory control plane. In the code, it is called G memory GMCP, Global Memory Control Plane, and GMDP, Global Memory Data Plane, right? The control plane is responsible for creating, deleting the memory space, and the data plane is responsible for adding events to the memory store, like the memories, listing memories, retrieving memories, right? And when I go to the code, I'll show you where I found that out, right? So let me go to the Python code that I created. So in my Python code, I created a memory function. So this is a agent code long-term memory class that I created. Within that, there is a memory function called create memory. In the create memory, I'm passing a default strategy of summarization. So basically, when somebody calls this create memory with no strategy, right, it will default to summarize session summary strategy, right? So when I create a long-term memory, I need to use the create underscore memory underscore and underscore wait, this function from the Bedrock Agent Core memory client, right? And it takes this parameters, like the name. I can name the memory. I can put a description of the memory, although it's an optional. event expiry days. So basically, if I add a memory to this memory store, till how long it will be there in the memory store before it expires. Um, Similar to the concept of like when I in the Kafka, right? If I put an event, default is 7, right? Similar to that. So although it's a long-term memory, I'm still probably saying that, okay, this long-term memory is going to expire when. And this is where I have some thoughts, right? So whether we should um, just default use an expiry of the memory, or we put an algorithm like the Ebbinghaus law, right, where based on the memory usage, right, how much I am using the memory, based on that I should expire it, right, similar to how it happens in human, right? If I'm not using a memory a lot, I tend to forget it, and then that follows the Ebbinghaus forgetting law, right? But anyway, this is something how it is there in agent code memory. Max wait is, so as I mentioned, there is a control plane, right? So when I say create memory and wait, the memory store, creation of the memory store underneath AWS might be using a lot of services, some storage services, not sure what storage services for the memory though, brings it up and then creates that. For that, it takes some time. So it says how much time the process should wait before the memory store is created. That is the max wait. Poll interval is like once I submit, it's an async way of submitting this memory creation, right? So every 10 seconds, it will poll for status whether memory is created or not, right? And finally, the strategies. This is where I put the strategy, the memory strategy. And this is a summary memory strategy, which is this session summaries, right? Summary memory strategy is that strategy where I name it as session summarizer. And namespace. Namespace is a mandatory thing, and this is what is not working for me right now. When I created it is able to create because these are placeholders. But then when I am trying to use it in the data plane, right? When it is trying to insert an event, that's where it is saying that the session ID I'm giving is, it doesn't follow a pattern, right? Although I got the regex pattern and I try to use the same pattern, it is failing there. And I'll show you the error as well, which I have logged already, right? The other memory strategy is the user preference memory strategy, where I get the name as your user preference. And here the namespace that it takes is users and actor ID. So actor ID is the actor in that conversation. The actor can be the user, the actor can be the agent, the actor can be a tool, right? And session ID is definitely like the session ID of that conversation. So this is my first piece of code where based on what, like, for example, here I'm trying to create a user preference memory. So let me go to my AWS. Let me delete this and we'll recreate it. It takes some time to create the memory. While it creates it, we'll go to the SDK code. You'll see some of the codes that the data plane and the control plane that I was talking to you about, right? So it is now deleting it. Deleting itself takes so much of time, right? Okay. So while it is deleting, let me actually create, since it is still deleting, probably it is using the same name, user pref memory. So I will change the user preference name to user preference 01, and let me submit this so that while we are looking at the rest of the code, it gets created. So I have submitted it. If I go here, I should see the other memory creation should start now. Let's see. It should start. Oops, no. Let's. Oh, yeah, it says creating, right? It started creating it, right? Okay. So user preference memory has started creating it. So while it creates, so if you see, it called GCMP, right? And from the GCMP, it submitted it and gave me the response back, right? It got a 200 200 status code, right? And this is where it is started polling it, right? So it is right now in the status is creating, right? And let's see about that GCMP thing. If I go to the create memory and wait, if I go to the strategies where it is actually, okay, um, where it is creating it. So this is where it is after submitting it, right? It is polling to get the memory status, whether it is created or not. Okay, create memory. So if I click here, then if I, yeah, so GCMP, see this, so GMCP. So what I think is GMCP is Global Memory Control Plane, right? This client instantiates this service, Bedrock Agent Core Control, and GMDP is probably the Global Memory Data Plane, which uses Bedrock Agent Core, right? Now, GCMP client that is responsible for creating the memory, right? This one actually, if I go here, create memory, it has this is the client, right? So this is the memory client, and the memory client has both GCMP and GMDP. It does the create memory, right? Then create memory and wait. Yeah, that's where it calls a create memory. But if I go to retrieve memories, I think here I should see the GMDP client. See this? So this is the global memory data plane. So the global memory control plane is responsible for creations. Okay, it is almost done now. So it is polling, right? So it has created it, right? But before we go there, before we go and see if the memory is created, um, so saying that retrieve memories is done by the GMDP client data plane. And let's see a few more. Create event. That should also be the data plane client. If I go here, payload.append runs, it should call the GMDP client, yeah. And then if I, the save conversation, let's see what it does in the save conversation part. Save conversation, yeah, here also it is calling the GMDP client. So anything that goes into the memory is handled by the data plane client. Safe turn is also the GMDP client probably. Okay, this part I probably will have to explore more. But this, yeah. So whenever list events, let's look at the list events. The list events is handled by, again, the data plane client, right? The list branches, right, is also by the data plane client. Let's see, list branch events, data plane client, right? Get conversation tree, also the data plane client. Merge branch content. Okay, there are some, these are probably some utility classes, right? But there should be some delete memory. So get memory strategies. That comes from, again, okay. Memory strategies are handled by the control plane client, right? Memory status is also the control plane, because control plane takes care of submitting the memories. List memories, so I was wrong. So list memories is not handled by the GMDP client, but by the GMCP client, the control plane client. If I have to, so basically list memory, so whatever the memory stores probably you have, that handled by the control plane, and delete memory also by the control plane. Delete memory and wait probably calls the GMCP client, right? Yeah. And this is something that I need to further investigate and see how to add the semantic strategy, right? So this is the code, that this memory client is a code. If we go through this memory client, it will be very easy to understand how they have architected the agent core memory, right? So now that our memory has been created, right? So this is the memory that has been created now. If I click on that memory, I need the memory ID because now I need to use it, right? So this is the memory ID. Now let's go to my strands agent with agent core memory.py. This is where I will now use it, right? To use it, here I created the agent core strands provider, agent core tool provider. Memory ID, I'll pass the memory ID that I just copied. Actor ID is my ID. I pass a session ID, although like for the namespace, it is not used. The namespace is the users and the actor ID, right? Then I'm creating the agent, passing it the stands provider tools, which is a long-term memory with user preference strategy. And this I'm running in loop, right? And asking questions to the user, right? So let me change the memory ID to the memory ID that just got created, right? And let me run it, right? So when I run it, so adding the events also, I did a time.sleep here 1 minute so that the memory, like when I push some memory, right? Yeah, I ensure that the memory is there in the memory store before I retrieve it, right? So let's say I like hiking mountains, right? So it will push it into the memory, right? I can move it, right? So if I go back here in the observability after some times, I should be able to see, let me say, yeah, see API invocation, right? So one creative event happened, 65 second latency, but it is still waiting because I gave a time.sleep of 60. I should have removed it. Right? Let me do that, otherwise it will take a lot of time, right? So I will remove the time.sleep. I'll run it again, right? And now I'll say, so I already said that I like hiking. I love non-vegetarian food, right? And now I should see that the API invocation should be true now once it it has still not invoked it. Otherwise, it should see that, yeah, it has invoked it. If I look at it, the invoke observability, I should see two now. Let's see. Yeah, two invocations. And now let's say I ask, okay, I forgot like what I told you, right? So what are my likings? It should be able to retrieve that now, that I like hiking and I love vegetarian food, right? So let's wait for it before it comes back, and after that we'll go to the observability and should be able to see how it let me see if it has already extracted it. No, not yet. So retrieve extracted memory, I should see an API invocation here. Let's see. Not yet. It is still taking this latency is a little more. I don't know why. Let's see again. Yep, API invocation latency. I should now see it back, right? Because it has retrieved, latency was 248 seconds, right? It should come back. Yep, it has come back now, right? Based on what I've recorded about your preference, here are your likings. Love non-vegetarian food, you enjoy hiking in mountain areas, right? And I can see that it has retrieved the extracted memory, right? But the long-term memory, extracted memory, I'm not sure what is the purpose of it. I was expecting this number should also go up, but did not, right? This probably will be, I'll have to do some more exploration, right? So that's what I wanted to show as part of the long-term memory. In the subsequent recordings, I'll talk about the semantic memory. And by that time, I think the session summary memory will also be taken care of. So that's all. Thank you. Let me